Hi 5M. So this is going to be lesson 3.8. It's going to be talking about tessellations. I think you'll have a lot of fun. You'll have two choices today. You can use your Pattern Blocks app, or you can also use the real pattern blocks. It's up to you, so just let us know which one you want. Okay? Enjoy! Alright 5M, it's time to get warmed up. On your whiteboard, please answer these questions. Press pause now. All right, welcome back. Let's go over these answers. First of all, what is the triangle called if all sides are different? This is actually called a scalene triangle. Draw a 3x5 rectangular array. That might look like this. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, 3x5 array right there for you. Write a prime number between 5 and 20. All right, well, we can start by counting up from 5 is 6 prime. No, it's not. 7 could be an answer that you could use. So let's think of some different answers here. Let's think there. You could use 7. 8's not prime. 9's not prime. 10's not prime. 11 would be another example. Remember, you only have to do one of these. 12 is not prime. 13 is prime. 14 is not prime, 15 is not prime, 16 is not prime, 17 is prime, 18 is not prime, but 19 is prime. So any of those answers would be great for that question. And then what are these two angles called when they're opposite of each other? One answer could be opposite angles, but the best answer here is what I'm looking for is vertical angles. Okay, those are the ones that are opposite. Remember, they have the same measure. All right, today, boys and girls, your learning target is I can make a regular tessellation. So we're going to learn what tessellations are, and we're going to practice making them. I think you'll have a lot of fun. A tessellation is a pattern formed by repeated use of polygons or other figures that completely cover a surface. So here below are some examples of some regular tessellations. Tessellations, a couple of things are important. One is the shape in a tessellations, the shapes never overlap, okay? They aren't stacked on top of each other. There are also never gaps between the shapes. You've really got to make them fit in there together. In a tessellation formed by polygons, a vertex point is the point where the vertices of the polygon meet. So for example, in this one, our vertex point is right there in the middle. Okay, it's where all of them come together. And around that vertex point, it always has to be 360 degrees. Why is that? Well, what else do you know that's 360 degrees? Hopefully, you're saying that a circle is 360 degrees. Okay, so the sum of the measures have to be 360 degrees. Remember, vertical angles have the same measure, so 70 and 70. And then if we have these adjacent angles here, 70 and 108 or 110 have to equal 180. Okay, so 180 plus 180, we have 360 there easily. Also, if the sum is less than 360, then there's going to end up being gaps in the shapes. And the pattern will not be a tessellation. It has to go all the way around, just like a circle, 360. If it's greater than 360, then that means the shapes are going to overlap. We've got too many degrees fitting in there. So here are some artistic tessellations. You might have seen this sort of thing before. Lots of times on blankets, you'll see patterns that are tessellations where they all fit really nicely together. This is the artist, M.C. Escher. He's famous for his drawings that show different tessellations. So study those, check them out. Remember tessellations, no gaps, okay, and no overlapping. All right, now we're going to talk about a specific type of tessellation called a regular tessellation. A tessellation made by repeating congruent copies of one kind of regular polygon is called a regular tessellation. So if you look at these over here, they're all made of regular polygons. That is key, okay? And then the other part about a regular tessellation is they're all congruent copies. So notice these are all the exact same size squares put together with no gaps, no overlapping. Right down here, they're all the same size, congruent, and shape hexagons put together with no overlap and no gapping. These are all regular tessellations. All of the polygons are regular and congruent, and this means that only one kind of regular polygon is used. So you're just using one shape. Okay? If the vertex of one polygon meets another polygon, the meeting point must be a vertex of both polygons. Okay, so your corners have to match corners. So like right here, you can see all of those corners matching up. Right here, all of them are vertexes coming together. Same here. Okay, we're not lining up a vertex with a middle. Okay, so let me show you what we're not doing. We're not using squares and lining them up like this. Okay, that's not going to be a regular tessellation. Your vertex has to hit your other vertex. They've got to be right next to each other. And then we can even clone that a couple times and line them up like this. Okay? And that would make that a regular tessellation. So all of my vertices have to come together at one point. Okay, the next kind of tessellations I want to talk to you about are semi-regular tessellations. Semi-regular tessellations involve more than one shape. Okay, more than one shape. These kind of tessellations are called, can be called semi-regular tessellations if they do these things. Okay, it has to have two different regular polygon shapes. Okay, so the last one just had one shape. This one has two regular shapes. If you look down below, we've got the square. Okay, and we've got a triangle, but they're both regular shapes. For each polygon shape, all the copies of that polygon are congruent, so there's no big triangles and small triangles. They're all the same size and shape, the triangles, and the squares are all the same size and shape. If the vertex of one polygon meets another polygon, the meeting point must be the vertex of both polygons. So same as before, we're not lining up vertexes with the middle of a side, okay? They have to meet all at the same spot. So you can see where I highlight these, it's a bunch of corners coming together, no corners / sides. Okay, 5M, what I want you to do is either get pattern blocks or your pattern block app and make a regular tessellation using just one regular polygon shape. Then show it to myself or Mrs. Conrad's. After that, make a semi-regular tessellation as well and have that checked, and then return to the movie. Have fun. Okay, so you must be back now. What I want you to do is we're going to open up to page 82 in your math journal. Up there, it just kind of reminds you what a regular polygon is. It says a regular polygon is a polygon in which all sides are the same length and all angles have the same measure. So circle the regular polygons below. Go ahead and do that. So hopefully when you circled those, you decided that this one was regular, same sides, they're the same length. And then hopefully you notice that the square, same length sides and same angles, and this one. Okay, if we look over here, all the sides aren't equal, all sides aren't equal, all sides aren't equal. So you have to have equal length sides for them to be regular polygons. Okay, now down below here it says, in the table below, write the name of each regular polygon under its picture. This in your book. Tell me the name of the polygon. Tell me, can it make a tessellation, yes or no? And then this part you can do the drawing, the example. You can either do it with blocks if you'd like blocks, or you can do it in your iPad. But you need to use these shapes and decide, can you make a regular tessellation with no gaps and no overlapping? Go ahead and do that now. Then have one of myself or Mrs. Conrad's check it. Okay, now that you're done with that, I want you to go back and make your own tessellations. And then when you get done, show it to me. Make sure there's no overlapping and no gapping, please. Go ahead and do that now. And after you finish, go ahead and work on your math boxes for this lesson.